Today we're going to continue with input and output, starting with output this time. Again, I've been cutting back on the amount of PowerPoint because I want to spend more time doing code. So we're going to talk about reading from the command line, and that's going to involve this strange thing called args that we've seen since the day of the first Hello World thing. We'll kind of see what that's about and how to work with that in NetBeans. And we'll begin by creating an output file from a string and writing some data to it. And then we're going to read that file and then work through some of the various issues that come about when we're reading with a file. These have been touched on a little bit, and I just want to go into them a little bit more in a little more depth. And then we're going to use the scanner to read the text file as we have done before. And then using that scanner, splitting and reading and parsing. Again, you've already done that with the movie assignment. And that was with a tab separated file. Now we're going to work with a comma separated file. And in the process also touch on working with maps and reusing one of our one of the classes that you've written before. So let's dive into the code, if I can find it. Okay, we'll do this in the IO piece. Okay, the first first we're going to create a file, and we'll do this just with the main method here. And we're going to start with hard coding what that file is going to be called. So I'll just call it output file. And it's going to be a comma separated file. Again, we've seen a tab separated file, a comma separated file, one of the most common forms of data. What's nice about it is it can have the same structure as a spreadsheet, which is why typically Excel and other spreadsheets such as Max Numbers and OpenOffice version of spreadsheets all will read a comma separated file and treat it as if it were a spreadsheet. One of the nice things is that because it's text, it's typically a lot smaller than the binary files that these spreadsheet applications typically use as their native format. And being text, it's also very compressible. And so you can have a ton of data. The other thing is that being text, there's not as much limit to how many rows you can have. In previous versions of Excel, just as an example, the number of rows you could have in an Excel file was something like 65,000. Okay, that sounds like a lot. It really isn't. So in the more recent versions, they bumped it up to about 1 million. And even that isn't enough for many data sets. There are a number of data sets that exceed the number of rows that you could put in an Excel spreadsheet. And in fact, that movie file was one of them. The movie file has more rows than can fit in Excel. So I don't know if anybody tried to open that in Excel, which you can, but it will only read the first 1 million or so rows. It won't, and then it just won't read the whole thing. On the other hand, your program was able to basically deal with the entire thing because it was, well, it was just kind of going through it like a text file. Okay, so here's an output file. We want to create the file. And so how do we do that? Well, again, the file this file class, instances of this file class are very useful for interacting with the file system. Now here's the thing. Now, since we're writing to a file, one of the things that you need to make sure, it's kind of the inverse of the reading a file. When you're reading a file, you want to make sure that it's there, or else you're going to get some weird stuff. And keep in mind that you can have a file object that is not null, that still doesn't point to anything on the file system. There are typically two reasons for that. The first is that you want to read the file and you've somehow fat-fingered the name. The second is what we're about to do here, which is we're about to create a file on the file system. And so we can create a file object, which at this point does not point to anything. And let's just sort of verify that. At this point, okay, there's this exists method. And when I run this should be false. Okay, so in other words, this file does not yet exist. Now, there's actually a very, very rich set of classes to write stuff to the file system. And of all those, if we're doing something as simple as text, we only need something much simpler. And that class is the print stream. Okay, so let's fix the import. So a print stream is what we've been using with member system.out, that we've been using both for printline and printf, which we talked about yesterday. That system.out is a variable of type print stream. And so everything that we can do to system out, we can do to a print stream. And what we can do with the print stream, as you can see, it's heavily overloaded, with constructors. So we can give it a file, we can give it another output stream, and we can actually give it the string that's a file name. The file constructor is more robust, because if we give it a string and that turns out to be a little bit flaky, then bad things can happen. So basically, we can now create a print stream which will output to the output file. And again, we have like a little red thing here. So whenever there's a red dot or a red squiggly, unreported exception, file not found exception. And so the solution to that is to, well, we could add a throws clause, but that's usually not the best idea. What we usually want to do is surround it with a try and catch. And I believe you mentioned that the exceptions were at least touched on a little bit in Java. Next week, we're going to dive a little bit more deeply into how Java does exception. Java has a very, very rich way of expressing exceptions, which is very useful, because when you're running a program, it's, nothing can possibly go wrong, go wrong, go wrong. So what's happening here is that, well, exactly what's sort of found. The file not found exception is presumably what happens if you can't find the file. In this case, the file hasn't existed yet. We're about to create it. So it's not clear when that's going to be thrown. And there's this finally, and when we talk about exceptions, we'll talk a little bit about what finally is about. And the pattern which we had in the movies assignment is just in general, whenever we're using system resources, typically on the file system, but other examples include connecting to a database, operating over a socket or a remote URL. Whenever we're doing something like that, you always want to clean up after yourself. This is basically the kindergarten principle. So when we're done, we clean up and put everything away. That's what's going on here. So the print stream, if, and again, I'll cover this a little bit more, but so here's this try catch. So if something goes wrong in here, then the file not found exception will be thrown. If you don't have this finally, then what happens is it just kind of, the whole program will exit. Thing is, you don't want to do that. That is, if you have set up connected to a system resource, and a print stream will do that, then we want to make sure that we close all the resources. And the thing is that it could be like if the exception gets thrown right when we try to instantiate it, the print stream could still be null. And in that case, if we try to close it, we'll get a null pointer exception. And you should be able to recognize that by applying some of the theory, if you will, that I kind of beat you over the head with earlier in the course. That is, this object reference, if we try to invoke a method on an object reference, you get a null pointer exception. And especially if you follow the principle of encapsulation, which means that you're never accessing instance variables directly, the only time that you get a null pointer exception is when you try to invoke an instance method on an object reference that is null. That's the only time that happens. And that's why, in a way, the null pointer exception is both the most annoying and actually the best exception that you can get, because there's only one cause of it. Okay, so enough of that. So what finally does is finally says, even if an exception gets thrown, what happens after finally will always get executed. So what this says is that even if an exception is thrown, if print stream is not null, then we'll close it. If it is null, then there's nothing to close. Okay. So what we're going to do is we're going to print a bunch of stuff here. And what are we going to print? We're going to print a bunch of rows consisting of comma separated values, which are going to be different random numbers. So to do that, let's have our random here. And let's have, like, say, 12 columns. And just to start with, just to sort of test this, let's just do 20 to start with. Okay, so we're gonna have 12 columns, 20 rows. Okay, so how are we going to, oops, we don't have to do it here, we have to do it out here. So first we're going to loop over the rows. Okay, so we're going to loop over all the rows. And on each row, we're going to print a comma separated row of numbers. And to that end, okay, now let's be a little more green about this and kind of just, we're going to use our string builder to do that. All right, so now over each row, I'm going to have a row of numbers that are separated by a comma, and each, so columns, okay, and you notice that up until now, we've mostly been using things like I and J, which are not very descriptive. Here, if I'm using names like row and column, that just kind of keeps it straight, at least in my mind, what exactly, we're doing. So we have two of these. And what I'm going to append is, let's, append like for each column. Now the columns go from 0, so the first one's going to be 0. So let's just do column plus 1. And okay, so they're going to be integers. Oops, next integer. There. Oh, yeah. Here's how I want to do it. I want to do it 1 plus that. How about that? Okay, so now I'm going to append my comma. And again, I could have chained that. And so now, after all that, remember, I'm going to have a row of these numbers. And okay, so I'm going to row these numbers, but it's going to end with a comma. So I want to delete the character at the last index of my comma. And once I do that, see now, I'm going to print that whole thing to my print stream, which is now going to write it to my output file. And then after I do that, I want to clear out since I'm being green and recycling my builder, I'm going to delete from 0 to the length of the characters are in the string builder. And the thing to understand about this, and again, if we control space and we look at delete here, you got to be careful about this, of course. But if we look, the two arguments are start and end. Start is the beginning index inclusive, and is the ending index exclusive. So again, normally when we're working with an array, the length refers to one more than the index that we have. That's the result of this silly zero-based indexing. So if I have, in this case, an array, or if I have under this, there are, let's say 25 characters in the builder, the array would go from 0 to 24, but because this is exclusive, that will delete all that. Okay, so, and then, okay, so let's see what happens. And we probably want to say something about this. So just to kind of let us know what's going to happen. And so I'm using a printf here just to write the absolute path, and then if I make it to here, okay, so I'm just going to let you know that it has been written. Okay, so now where is it? Okay, so I look in my projects here and I don't see, now where the heck did it put it? By default, it puts it in the, what was that, user directory. But where is it? In NetBeans, it's not, we can't see it in the projects tab, but if we click on the files tab, we see everything that's there, and there it is. And we see that there are a bunch of numbers that have been written. And kind of looking at that, rather than this, I tell you what, let's make, just to make life a little more interesting. Let's okay, let's make them doubles. Okay, now here's the thing. Here's where we need to be a little bit more careful. If you're, let's say you're running an application, let's say you're writing a Word document, and you go to save it, and you give it the name of a file that's already there. What does Word do? This is one of the few cases where Microsoft does the right thing.
Puts it in parentheses and a 1 beside it.
Pardon me?
It'll put parentheses at the end of the shared name and a 1 within the parentheses.
Well, before it does that, well, what mine does is if I go to save it to a file that's already there, it will bring up a little dialogue that says, hey, this file exists and will be overwritten. Do you really want to do that? If yours does something different, then maybe we have different versions, but at least mine does. In other words, it does the right thing. It says, okay, you're about to clobber this file that's already there. Do you really want to do that? Okay, so we're not going to go quite that far. We haven't covered Java's graphical user interfaces stuff yet. We will, but we at least want to alert the user that something is going to be happening. So if the output file exists, we're just going to, let's just sort of print a, and let's do it as a printf as a warning. or written. Okay, so in other words, if it exists, we're going to say, hey, watch out. So what I'll do is first I'm going to actually delete it. And now if we run it, nothing happens. But notice that it wrote it. And if we run it again, now we get the warning. And you notice that I wrote that instead of the system out, I wrote it to system error. And system error is for error messages, and NetBeans prints those in red just to kind of alert us to that. And we see that our output file now has a bunch of real numbers in it. Okay, so we managed to create and write a file. Now the next step is let's try to read that file and sort of do something with it. So what we're going to do is we're going to read that in, and we've done stuff like this before, but now what I want to do is I want to read the name of the file from the command line. So since the beginning, we've seen this public static void main method with an argument of an array of strings called args. It could be called anything. By now, you understand what each of these means. So public means who can see it. Static means that it's a class method. Void means that it doesn't return anything. And main is simply the name. This is one of the few special names in Java in that if I execute this class, then it will start executing this main. Now, you know what an array of strings is, and you know what an argument to a method is, but what the heck is that? What that is this is the array of things that are entered on the command line. Now, what's the command line? Well, back in the days when dinosaurs ruled the world, all programs were run from the command line. So on Windows, that was the command prompt, which was basically like the old DOS prompt. And on Linux systems, it's a bash shell. On Macs, it's this thing called terminal, which is also a bash shell. So what we're going to do is, this is a way that information can be passed to the program. So okay, so in other words, this is an array of strings, and that's going to be our file name. However, what if there's nothing there? So the first test, as an array, if it's 0, we're going to also print another error. And here we can make it a print line since we're just okay. So now if I run it like this, it says, please enter a file name on the command line. In other words, if I just kind of run it by right-clicking, then I don't get anything on the command line. So how can I get something on the command line? Well, that's where this little business up here is. See this little drop down? If I want to customize that, I can create a number of different ways of running programs from this project. So I'm going to create a new configuration. I click on new, and and I can call it anything I want.
Arnie, we can't see your pop-up screens.
Oh, drat. Okay, darn. All right, sorry. Let's, I need to share the whole freaking thing. Okay, can you see it now?
Yes.
Oh, thank you. Okay. I wish Zoom were a little better about showing pop-ups, but it isn't. All right. Okay, so what did I do? I clicked on, I just opened up this combo box, click customize, and now I can create a new configuration. I say new. Okay, now it suggested a main class, but that's not the one that I want. I can hit browse, and if you remember the last time we did this, there was only one there. Now we have a whole bunch of things. And what I'm looking for is this one. So I'm going to select that as the main class. And right below it is a text field called arguments. And that's where I can put my command line argument. So here, all right, and also I want to, right here, let's just see what that did. Okay, now if I just run it like right-clicking on the file, it still, there's nothing there. But if I run it now from the green arrow with read file selected, then I say this will be read, and I want to put an end there. However, that doesn't guarantee that that file exists. So I want to do the same deal as before. If the input file does not exist, okay, so let's sort of test that. So how can I, let me just sort of fat finger this. And now when I run it, it says, okay, I can't find that file. Okay, so if you're going to read a file, it had better be there. So let's make sure it's sort of right. And then now when I run it, it says, okay, I can't run it by right clicking, but now I'm going to read that. Okay, so now we're all set up. So this is how you read something from the command line. And what this lets me do is this means that now the same program can be run without having to edit and recompile. The same program can be run with different inputs. That's much more flexible. Okay, so as before, we're going to use our scanner. And use the input file. Again, as before, we will surround it with a try and catch. And then notice that I I do all this first. Because if I don't, and your mileage may vary, if I don't do this right away, I may forget it later. And if I forget it, then okay. So now here's what I want to do. What I want to do is I want to read, I want to compute the average of each column by the column. Okay, so how do you understand what I'm doing here? First of all, I don't know how many columns there are beforehand. But no matter how many columns there are, I'm going to assume that they're all at least double values. That's a little bit fragile, but for now we'll make that assumption. And so each column, I want to compute the average of each column by the column. So now how can I do that? Well, I can do that with a map. Okay, remember the statistics calculator that we have. Again, this is one of the benefits of object-oriented programming is that we can reuse these classes that we had. So my task was to compute the mean. Now that's a fairly straightforward thing, but rather than just kind of doing it like that, I already have a class, statistics calculator, which does that. I just kind of stuff values into it and it will report the mean to me. I don't know how many columns there are going to be. And so my strategy is going to be to read each line, split it up into by the commas, and then parse each of them into a double, and put that double into the corresponding column that it was in. Okay, so there are a number of different ways of doing this. Let's say as next line. So as long as the scanner has the next line, line. Okay, so now I've grabbed one of the lines, but now it's a comma separated one. So I'm going to split it into strings. And I'm going to split it using a comma. And actually what would be a little safer would be to also include spaces. So there, now in this case there aren't any, but if somehow spaces get in there, I've seen a lot of different data sets in which the numbers are there, but they have spaces in them, and we want to make sure we split around that. Okay. Now, so here, this will tell us how many columns we have. How many do we have in this row? We'll have as many as there are the length of our array. Okay, so now we have the same deal as before when we were working with dynamic maps. So we first want to check. So if our stats contains the key of the column, if it doesn't, then let's put a new simple stats, a new statistics calculator in keyed by that column. And so now we can guarantee that column is there, and we can put our new observation in. Okay, I'm doing a number of things here, so let's see what that is. By the time I do this, I guarantee that there's going to be a statistics calculator object in that column. So this is safe. As a statistics calculator object, it has a method called new observation that wants a double, or it will take an integer if it would happen to be there. And this is, so splits of the column, that's the one that I'm reading, because this is all wrapped in this for loop. And then parse double takes the string and turns it into a double. Okay, so, and if I do that for the whole thing, then I should, by the, let's see now, where, by the very end here, okay, so now I just want to print out my results. Oh, let's do 4 decimal places and a new line. Okay, so again, we're using this printf that we had before. So we have the column and the mean. And now, if we enter a file name, we see that each of the columns, 0 through 11, the 12 columns, are, we can now report the mean for each of these. And the question now, to get back to the file that we created, we only had 20 rows. And what I could have done is I could have put the number of rows in the command line for this, but let's print 1,000,000 rows. Takes a little bit longer. And there are fancy, if you're doing stuff like this, there are fancy uses of buffers and stuff like that, but we will probably not get into, but you just need to be somewhat aware of it. In fact, here, just as for this, every time we read a line, let's increment number of rows, and then when we're finished, let's just sort of print out how many number of rows we actually had. And so now, okay, it takes a little bit longer to read that many, about 8 seconds, which is, and okay, so it read all 1,000,000 rows, and then now we see what the means were. Okay, so just to review, We've learned how to create a file. We've learned how to at least warn the user that the file will be overwritten. When we start talking about graphical user interfaces, we will be writing that pop-up dialog that says, oh, by the way, you're about to write over a file. Are you sure you want to do this? And so, in other words, getting the user's confirmation for this here, we could do something like that, but it would be a little bit, well, maybe we'll take a look at that at some other time. Okay, so we wrote a comma-separated file that was, in fact, if I try to open this, NetBeans will kind of complain. It seems to be too, so let's not open it there. And if we made a few more, then we couldn't even open this in Excel. But this, as it is, it can just barely be opened in Excel if you want to sort of kind of see what's there. So just we've used the print stream to just write to a file. And also, you know, re-emphasize something that we've done before, which is catching the exception, making sure that we close our system resource, and use the string builder to, and in this case, we're reusing the same one. I could have created a new one. It wouldn't have been the worst thing in the world. But just to kind of show you how we can reuse the same one. Then as far as reading goes, again, this is somewhat review, but we showed how to use the command line, what this command line is about, and how in this particular case, sort of say to make sure that we actually enter something there. And if something is there, then we can kind of grab it and say, oh, here's the file. And then when we run it, we just sort of verify that that's the one we're going to be running. Then in this particular case, we're using a dynamic map to collect data on a data set that we don't know how many rows there are, and we don't know how many columns there are. If I were to write with different number of columns, then this same reading program would work just as well. Okay, so that's the topics for today. And if there's nothing more, I will see you tomorrow.